Hello everyone, this is Dr. Wu. Today I'm going to demonstrate how to do this lab 4 electric current. As usual, we go to Beyond Labs and find this physics, click open. It will bring us to this page showing the categories, different categories of those labs. Under this worksheets, find electricity and magnetism. Then open that tab and find electric. I think it's electric current. Yes, that's correct. So there are three parts. Let's look at this lab instruction first. There are three procedures. I hope you already read the previous one, the above instructions. We start from this schedule section 1, single resistance. So this instruction was not very good because it didn't match the lab setting. So just follow me on this, you will get the result. So this is electric current. So we're going to learn about the current when there are different resistors in the circuit. So that's the purpose. And just skip those steps and back to this one. So the resistor just one. So let's switch to the pad paper, or they call this engineering paper. So it's already laid those three different circuits for us. So we start from the first one in this schedule 1. Here, that's the resistor 100 ohm, then the power supply, that's this DC battery. Then the current is measured by DMM, means digital multimeter. So we'll go to the battery source, increase the voltage up to, let's see, 12 volts, the maximum. So then we can measure this. I think that's the okay. Let's measure in. Okay, it doesn't show the number. Let me put this one in. Okay, yeah, that works. So I bring the electric, that's not the DC battery at the beginning, so sorry about this. I replaced that with a DC battery. So now you see the in part. Let's see, let's go, it should be on this part. I will disconnect first. the current goes from a positive end and go through a resistor, then back to negative end of the battery. Then this part is called current in, and this end is called current current out. So we'll measure the current in. So you can record this number. So we can save it in the lab book. Then click here, disconnect, then connect it again in this out end, at the end when this current is out. So it's the same, there's no change, 0.12 ampere. Then the question one asks, if we add more in this current, what will happen? So we'll test for that. So disconnect this end, then add one more the resistor here. So let's connect this and then so we include one more resistor in the circuit. So now let's measure the in current. So it's changed. It's 0.06 ampere. How about out? So out and at out, current out should be here. Let's put this end. So it's the same 0.06 ampere. Now it reduced. Then you can predict if we add one more and the third one in the circuit. So let's do this. One more in the circuit. Okay. Okay. So, number 1, number 2, and 3. So now 3 in a circuit. So let's measure the current in down further, 0.04 ampere. How about the end in here? Okay, the 0.04. That's the result. So you with this data, you can answer question number 1. Sure. It asks what will happen to the current if more resistors are put in the circuit. So now you get the numbers put over here, 1, 2, 3, then different number, you see the change. So we finished the first part, schedule section 1. Now we move to this section 2. So in section 2, you just ignore those parts. You focus on the 3 resistors, and they have different value: 150 ohm, 180 ohm, 100 ohm. That will measure current in and current out. Yeah, you can put number in those blanks. So let's remove the first part and just put those resistor back, and we need the DC electricity power. So we can connect them on this side and on this side as well. And now, yeah, 3 in one in a serial. So the question, ask, what's the in for before, the current in before 150 ohm resistor. So that's 0.028 ampere. Then we disconnect, then connect it again at this end. So that's the out. Now out is the same 0.028 ampere. So you can fill first blank, use those the numbers. Then we put the probe here to measure in before 180 ohm. It's the same, nothing changed, 0.028 ampere. And out, the same. So then the in before 100 ohm in this circuit, nothing, and no change. There's no change. So on the 12 volts, the current is 2.028 ampere. So with the data we collect, you can answer the question in question 2. So how does the 3 resistor circuit arrangement affect the current? So do you see any change when this current is out? Now we can move to procedure section 3, parallel resistors. So just ignore this part and we'll focus on the settings on the engineer paper or pad of paper. So there are 4 of them. Let's see. Yes, 4 of them over here. First, let's detach this and put those resistor back to the folder and bring the DC power here. And connect on this end and that end. So that's our, let me change this to see, maybe this way to look. No, okay. Then the question asked, let's see what the question asked. So how does the data show this? So we'll measure the current in before 1 ohm, 1 kilo ohm, and 200 and 500 ohm. So let's measure this. The first, before 1 ohm, we bring the probe here. Okay, that's the current in the circuit. It is 0.095 ampere. Disconnect and connect on this side. That's the current out from 1 ohm resistor. There's nothing changed, 0.0 0.95 ampere. So you can record this number here. Then we'll measure the current in before 1 kilo ohm. So it's 1,000 higher than the first one. So now it's 0.012 ampere. Then we disconnect and connect it again. And there's nothing changed for the current to go through this resistor. So we'll measure the current before 200 ohm resistor. And that's 0.06 ampere, it changes. So how about the end, the out? So the out, there's no change. So that's the this number you can record, put in the blank. Then the last one, that's before 500 ohm resistor, is changed to 0.024 ampere. How about out? Out, you will see there's no change, 0.024 ampere. So I think that's all for today's lab. And with those data here, you can answer the question from 3 up to 8. I will see you next time. Bye-bye.